Hey everyone, so we're going to take a look at solving polynomial equations by factoring specifically. So this is a continuation of the last lesson that we did. So solving polynomials by factoring, we're going to move all terms to one side and set the equation equal to 0. Factor the polynomial completely, set each factor equal to 0, and solve for each x value. For quadratic equations solved by square roots, completing the square quadratic formula, simplify all irrational and complex solutions. So there's various answers that we're going to get with this. But the idea is that pretty much we are going to actually find out where they would cross the x-axis in theory. So we're going to take a look at that I do. Oh, look at that. I switched them. So I do need to fix that. This here should say we do. This one should say I do for those in class. So I will fix that. So we're going to take a look here at this first one, which is actually number 2 on your notes. We're going to combine like terms. We're going to move this 3x squared over from both sides and get 4x cubed minus 10x squared equals 0. So now that it's equal to 0, we can go ahead and start factoring. So I can see that they have a GCF of 2 for the 4 and the 10, and then x squared. So we're going to divide by 2x squared on both of these, and we get 2x minus 5 equals 0. So now set each factor equal to 0. So 2x squared equals 0. 2x minus 5 equals 0. And we're going to head solve for x. So over here, we divide by 2. X squared equals 0. I can take the square root, but we should already be able to jump to x equals 0. Typically, whenever we have an x on the outside like this, whether you're multiplying, raising it to a power, the answer is going to end up becoming x equals 0 for our solution. For the second one, we're going to head and add 5 to both sides. We get 2x equals 5, divide by 2, and we get x equals 5 halves. So our answer here would be x equals 0 and 5 halves. I do believe that would be in a solution set. So next we're going to take a look at number 1.
Please remember to submit your attendance at this time.
Taking a look at number 1, it's already set up for us in GCF, so we would take a look and see what both terms have in common. They both have x in common. So when we factor that out, we're left with x squared plus 1 equals 0. So we're going to set each factor equal to 0. The first one's done for us. Second one, we're going to subtract by 1. And at this point, it should be a review from when we did quadratics. And so we take the square root of both sides. So x equals plus minus I. So do recall that the square root of -1 is I. So that is something that you need to recall from quadratics. As always, pause the video as needed. I do want you to go ahead and try questions 3 and 4 off the notes. Or if you're just watching the video, just go ahead and give them a try. Pause the video. Okay, let's go ahead and check your work. So we have a couple ways we can actually do number 3, but we're going to go ahead and do difference of squares since that's what we covered in the last lesson. So this will factor into x squared minus 8 and x squared plus 8. Now, since this here, this first one's not a difference of 2 squares because 8's not a perfect square, we can just go ahead and set each of these equal to 0. We have x squared minus 8 equals 0. X squared plus 8 equals 0. So we're going to solve for x. We're going to add 8 to both sides. X squared equals 8. I take the square root of both sides. So this, remember that 8 will break into 4 and 2, because we do always want to break it into our perfect squares. So we get x equals plus minus 2 square root of 2. We're always going to do a plus minus for those, because you never know if I want the positive or negative root. Over here, we're going to subtract 8 from both sides. X squared equals -8. We're gonna take the square root of both sides. And this one's pretty much the same thing. The only difference we have here that's different is actually the negative. So we're gonna break this into the square root of -1. Actually, I'm gonna break this into the square root of 4, -1, and 2. So that when we do that, we're gonna get our plus minus 2 from the 4. -1 becomes I, and we keep the 2 inside. For number 4, it's already set up. Feel like this looks like something we did on our previous notes, but we're gonna do it again anyways. We're gonna factor out 5x for the GCF, and we're gonna be left with x to the 4th minus 16. So I'm gonna break this into my difference of squares, which would be x squared plus 4 and x squared minus 4. And I'm actually not done. We're going to go ahead and we have another difference of squares here, x plus 2, x minus 2. So when we had that set, the directions in the notes that says factor completely, this is what they mean, is that they want to make sure you have as many factors listed as possible, and they should be equal to 0. So now that it's factored completely, we're going to set everything equal to 0. So 5x equals 0, x squared plus 4 equals 0, x plus 2 equals 0, and x minus 2 equals 0. Based on the previous slide, we already know this one's going to be x equals 0. We can go ahead and just work our way through. X squared equals -4 because we're going to subtract 4 from both sides. And take the square root of both sides now. And we get x equals plus minus 2i. Over here, minus 2, so x equals -2 plus 2 plus 2, x equals 2. And I just realized I didn't finish writing on the previous one, so we'll do it. So x is going to be the set of plus minus 2i, 0, -2, and 2. Which I could actually write this as plus minus 2 if I wanted, like this. Or you can break it up into 2i, -2i, and then 2 and -2 if you want to, depending on how they want you to write your answers. I did forget to write this as my set over here. So this here would be the set of, x is the set of plus minus 2 square root of 2 and plus minus 2i square root of 2. It all depends on how they want you to write your answer. Just look at the directions. Usually they're a bit more specific. So I do want you to go ahead and try these 3 problems. All right, let's go ahead and take a look at number 6. As we can see, it is not set equal to 0, so we need to move everything on over. So we move the 4x squared over by subtracting it from both sides. And we're going to get plus x squared. We're going to factor out the GCF, which would be an x squared, which is going to be 8x cubed plus 1. So from last class, we should realize that this is a sum of 2 cubes. So this will, if I can get it right, factor into 2x plus 1, 4x squared minus 2x plus 1 equals 0. So we're going to do a couple options on this when we're solving for these. Set everything equal to 0, so x squared equals 0, 2x plus 1 equals 0, 4x squared minus 2x plus 1 equals 0. I'm going to get x equals 0 here. 2x equals -1, so we're going to subtract 1 from both sides. Divide by 2. X equals -1/2. Did not realize how ugly that last part's going to be. We're going to do quadratic formula for this last section. For this one here, we're going to do quadratic formula, which again is -b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to do that for this last section. So when we plug in 4 for A, -2 for B, and 1 for C, we would get -b, so +2 plus or minus the square root of -2 squared minus 4 times 1 all over 2 times 4. So we're going to get 2 plus or minus 4 minus 16 is -12 over 8. Yeah, -12 over 8. So this becomes 2 plus minus 2 times 6, 12, 2, 4 times 3. That's what I needed. So this becomes 2i squared root of 3 over 8, which would simplify to 1 plus or minus I squared root of 3 over 4. So we go ahead and take a look at the next part.
Please remember to submit your attendance at this time. Thank you for a great day of teaching and learning.
I was waiting for the announcement to be made. So here we go with the next one. Like I actually would highlight, here's all my answers. Those would be all my answers. I forgot my x equals. So next going on to number 8. I would subtract 54 from both sides to get 16x cubed minus 54 equals 0. And we're going to go ahead and factor out, I believe, 16. No, we're just going to factor out a 2. We're going to factor out a 2, which would put me at 8x cubed minus 27 equals 0. This is the difference of 2 cubes, so this factors into 2 times 2x minus 3 times 4x squared plus 6x plus 9 equals 0. Since this 2 doesn't have a variable with it, it doesn't actually, nothing happens with it. We're not going to include it in our setup of setting equal to 0. We're going to do 2x minus 3 equals 0. 4x squared plus 6x plus 9 equals 0. We're going to go ahead and solve for x. Add 3. 2x equals 3. Divide by 2. X equals 3/2. We're going to go ahead and do quadratic formula again. So we're going to get -6 plus or minus the square root of 6 squared minus 4 times 9 all over 2 times 4. So that's going to get us -6 plus minus 8. 36 minus 4 times 36. 4, carry the 2, 12, 124. Which is really times 3, so 6 times 3 is 8, carries a 1, 108. No. 24, 12. This would have been 4. This would have been 144. There we go. I'm glad I checked my work, because otherwise I would have gotten the wrong thing. So we're going to get the square root of negative 108. Which is going to be 36 times 3, which I should have known that because I had 36 times 3 up there. So negative 6 plus or minus 6i square root of 3 over 8. All the numbers on the outside are even. So we're going to get x equals negative 3 plus minus 3i square root of 3 all over 4. And in cases like this, it does help to write your answer somewhere. Square root, oh, I've got the I. There's my final answer. Tell me 10 is a pretty answer. Okay. All right, moving on to 10. I personally like to have a positive leading coefficient, so I'm going to add 9x squared to everything, or 9x to the 4th. And I'm going to subtract 13, which gets us 10x to the 4th minus 10 equals 0. So I'm going to factor out a 10 and get x to the 4th minus 1 equals 0.
At this time, all students must exit the building unless accompanied by a teacher or coach. Those found inside without supervision will face disciplinary consequences such as school suspension.
Okay, so we're going to go ahead and just finish the factoring. So I'm showing all the complete factoring for the problem. So we have, when we have a difference of squares for x to the 4th minus 1, which gets me x squared plus 1 and x squared minus 1. We have a difference of squares still within that. So that x squared minus 1 becomes x plus 1 and x minus 1. So we're just going to set all these equal to 0. I'm going to solve this one right now so I can have it on there. So this is x equals negative 1. We're going to do x minus 1 equals 0. Since we add 1, and we get x equals 1. Over here, we're going to subtract 1 from both sides. X squared equals negative 1. So we take the square root, and we get x equals plus minus I. So my final answer for number 10 is x is equal to the set of plus minus I and plus minus 1. That's how I'm going to write that because I am running out of space. As always, pause the video to make sure you have time to copy everything that you need to or to review anything you might need. Moving on to our next example that we want to look at together, we're going to take a look at number 14 together. For those of you who have the handouts. Just a bit longer. This is going to be more of a trinomial than anything else. Actually, this is going to be a quartic function, or no, sorry, not four terms. Polynomial, so we're going to subtract 2x from both sides. We're going to subtract 18 from both sides. We're left with 5x cubed minus 3x squared plus 30x minus 18 equals 0. So based on the previous lesson or what we did in the first factoring, we're going to do factor by grouping, first two, last two, and we find the GCF of each group. So in this first group, the GCF is x squared, and we're going to be left with 5x minus 3. In the second one, we always take the sign that's in the front, so we're going to take the plus. 30 and 18 are both divisible by 6. So we're left with 5x minus 3. Again, as we do these, our parentheses should match. That's going to make one factor, 5x minus 3. The other factor comes from what's in the front, which is going to be x squared plus 6. And that's completely factored as much as possible. So we're going to set both equal to 0. Unsolved, so we're going to add 3 to both sides here. 5x equals 3. Divide by 5. And we get x equals 3/5. Over here, we're going to subtract 6. And then take square root of both sides. And we're left with x equals plus minus I squared of 6. The only thing I can do is pull out the negative. So our final answer is x is the set of plus minus I squared root of 6 and 3/5. Take a look at our last two equations. We're going to take a look at questions 12 and 16. Again, if you have the handout, they're there. If not, you can copy them from the screen. Go ahead and try these problems. So go ahead and pause the video, give them a shot. Okay. Moving on, let's go ahead and take a look at them. So let's check your work. On 12, there's nothing to combine. All I can do is go ahead and start factoring out. So I see they are all even. They're all divisible by 2. And that they all have, I can factor out an x squared. So this will give us x to the 4th minus 5x squared minus 24 equals 0. We're always going to keep that GCF in the front. So for negative 24 and then negative 5, we're going to do 3 minus 8. So this becomes x squared minus or plus 3, x squared minus 8 equals 0. And that is all the factoring I can do. So I'm going to set everything equal to 0 now. As we talked about that first problem, this is just going to be a 0. Subtract 3 from both sides. Take the square root of both sides. And the only thing we can take out is that negative to make it I. So plus minus I squared of 3. We're going to add 8 to both sides here. Take square root of both sides. And we're going to get x equals plus minus 2 square root of 2. My final answer would be plus minus I square root of 3, 0, and plus minus 2 square root of 2. On 16, it's already set up for me, so we can just do factor by grouping, first two, last two. So in the first two, they have x squared in common, which will leave us 2x minus 3 on the inside. On the other, we take the minus from the 32, and they're both divisible by 16. So we get 2x minus 3. Again, our goal is always to have our parentheses match. So when they match, we have 2x minus 3, and then we have x squared minus 16. So we can continue factoring this one. X squared minus 16 is a difference of 2 squares. So this is going to be x plus 4 and x minus 4. So now that they're completely factored, we're going to set them all equal to 0. And we're gonna hit solve, so add 3. So 2x equals 3, divided by 2. X equals 3 halves. Minus 4, x equals -4. Add 4, add 4. X equals 4. So my final answer, x is the set of, we'll do 3 halves and plus minus 4. That's a weird squiggly bracket, but it is what it is. So next we're gonna move on to the word problem section, or the applications of solving. So our application basically is, in math, usually that means a word problem of some sort. I'm gonna give you information, and you're gonna have to know different things. So starting off with, we're gonna do the area of a trapezoid. So for this one, you actually need to know the formula for area of a trapezoid. So area of a trapezoid is going to be, it's 1/2. I'm gonna double check this formula for myself. I'm always not as sure on areas of trapezoid. It's been a while since I've seen those. It's 1/2 of base 1 plus base 2 times your height. So you might see this a couple different ways. You might see this as b1 plus b2 over 2 times h. So there's a couple ways you might see that one. But that is the formula for area of a trapezoid. I just wanted to double check that one before I start using the wrong formula. Okay, so if area of the trapezoid below is 30x plus 20, so this here is my A for a given my area. Find the area of, I'm very confused on this one. Find the area of the trapezoid. I'm just going to assume it wants us to solve for x. Yeah, I'm assuming it wants us to solve for x. Oh, they want the actual value of x. They want the actual value in feet. Got it. For those that want to know, no, I did not look at this problem before I started working it. So we're going to do 30x plus 20 is going to be equal to 1/2 times x plus 5 plus 5x minus 1 multiplied by x squared plus 1. Oh, dude, how lovely this is. So we're gonna do 1/2 times 6x plus 4 times x squared plus 1. Okay, that's what it's missing. So we're gonna go ahead and actually apply this 1/2 to this first section here to give us something smaller to work with. So 3x plus 2. Let's make this actually look like a 4. Which gives us something that gives us much smaller things to deal with. But this is going to be equal to 30x plus 20. So we're going to go ahead and multiply this set here. I'm going to do a box. 3x plus 2, x squared plus 1, 3x cubed, 2x squared, 3x plus 2. We're gonna get 3x cubed plus 2x squared plus 3x plus 2. So now we subtract 30x from both sides and 20 from both sides. Interesting, that's a multiple of 10 that I'm off on both of those, but I digress. 0 equals 3x cubed plus 2x squared minus 27x minus 18. I'm going to go ahead and do factor by grouping. I want myself for x. I'm going to do first two, last two. X squared 3x plus 2 minus 9 3x plus 2. So x squared minus 9. Do our 3x plus 2, since that's my parent. And then we have x squared minus 9. And again, I should have probably worked this out on a sheet of paper first. So 3x squared, or not 3x squared, 3x plus 2 times x plus 3, x minus 3 equals 0. So we're gonna go ahead and solve for these. We get 3x equals -2, x equals -2 over 3, x equals -3, x equals 3. Now, when we're talking about area and all that, we can't have negative answers. So this is a no, this is a no. So my only possible solution is x equals 3. So they want you to plug in x equals 3 to our area. So we're gonna do 30 times 3 plus 20. It's an ugly parenthesis, so let's fix it so it looks like a parenthesis. So 90 plus 20 is 110 feet is my area, feet squared per area. Yeah, so lovely, so lovely. I probably should have done a bit better prep on that one. As always, pause the video. But we're gonna move on to the 17, which should be a bit more familiar on the formula. So we have a rectangular prism with the dimensions x minus 3, x minus 1, x minus 8, has a volume of 33x cubic units. What are the dimensions of the prism? So we should know that volume is going to be length times width times height. In this case, I don't care which one you make each one. I just want to know which one each is. So we know that my volume is 33x. It's the same thing as x minus 3, x minus 1, x minus 8. So we're going to go ahead and multiply these through. We're going to do x minus 3. We'll leave that one alone. And when we multiply these, we're going to get x squared plus 8. -1 plus -8 is -9, so minus 9x. So 33x equals. So when we distribute here, we're going to get let's see, we're going to do x. I'm going to do a box. The better answer is to do a box here. X minus 3. X squared, -9x, 8. X cubed, -3x squared. -9x squared. -20 or positive 27x. -24 and 8x. So when we get this, we're going to get x cubed minus 12x squared plus 27 plus 8 is 35x minus 24. So I'm going to subtract 33x from both sides to start solving for it. So we get 0 equals x cubed minus 12x squared plus 2x minus 24. First two, last two. X squared leaves with x minus 12 plus 2 times x minus 12, x squared plus 2, and x minus 12. So when we start solving, x squared equals, or plus 2 equals 0. If I could write at the bottom board here. Subtract 2. I get x squared equals a negative number. This isn't going to work for me, so I'm not even going to continue it. X minus 12 equals 0. X equals 12. That's a real number. I can use it. So we're just going to plug it in. 12 minus 3 equals 9. 12 minus 1 equals 10. 12 minus 8 is 4. And I lied. 12 minus 1 is not 10. It is 11. So it's, we're just going to add units here. So those are my units of measurement of however they would like to use them. So go ahead and take a look here. That's not the right place. As always, pause video is needed. So I do want you to go ahead and try number 19. I am going to help you with this setup before you start it, though, mainly because of how it's written. The revenue R in thousands of dollars for a small business can be modeled by the formula R of t equals 2t cubed minus 12t squared plus 3t plus 57, where t is the number of years since 1995. In what year did the revenue reach 75,000? The key part here is the fact that I already said it's in thousands of dollars. So that when you're setting it up, your setup should be 75 equals 2t cubed minus 12t squared plus 3t plus 57. Because it's already in thousands and this is, divide that by 1,000, you get 75. All right, so go ahead and try 19. Let's go ahead and check your work. So the first thing you should have done was subtract 75 from both sides. And so we would have 2t cubed minus 12t squared plus 3t minus 18. So we're going to do first two, last two. And we are going to have 2t squared. And that leaves us t minus 6. Plus 3, so t minus 6. So we get 2t squared plus 3 and t minus 6. So we're going to set each of these equal to 0. I'm going to be honest, I'm like, oh, this one's just going to be 6. Probably the one I want, but I'm going to do this one anyways. Subtract 3. 2t squared equals negative 3. That's not going to work. I'm going to get t squared equals negative 3 halves. I'm not even going to finish it. So t is 6. So 1995 plus 6 is 2001 is the year that they reached $75,000 in revenue. I'm going to head and go to our last problem. Again, I want you to go ahead and try this one, and then we will come back and check your work. Do go ahead and round to 2 decimal places on this problem. All right, let's take a look here. So we have P of t. When is it expected to go extinct? So that would mean I have a population of 0. So we're going to do 0 equals negative t to the 4th plus 72t squared plus 225. The only thing that I would recommend doing here is actually factoring out a -1. It just works better when our leading coefficient is positive. It just works out a little bit better for us to make sure that all our signs end up the way I want them to end up. So I'm gonna go ahead and do my lovely little x here. I want -225 up here, but -72 down here. Okay. So remember, we are multiplying to get the top and adding to get the bottom. So let's get 225. That'd be 1 and 225. That's not gonna work. 2 is not gonna work. 4, 3 will. Let's see, 3 times 75. And I can use that to get to 72. So I'm going to stop because the next one I can think of is 5 and something. 5, 45. Maybe it's 45. Minus 20. Yeah, 45. I can't get 72, 35, and 45, so that's probably my best bet. I said I can't. So we're gonna use 3 minus 75. So -1, and this is gonna become t squared plus 3, and then t squared minus 75. I can't factor that any further, so we're just gonna go ahead and start setting them equal to 0. So t squared plus 3 equals 0. T squared minus 75 equals 0. So we're gonna take t squared equals -3. T equals plus minus the square root of I, so this is not gonna work for me. Over here, t squared equals 75. I should take the square root of that. So that's going to get me 5 square root of 3. I want plus minus. I probably want the positive one, so plus 5 square root of 3 is my answer. And using the calculator, that's going to be about 8.67 years. The reason we're going ahead and moving this one to a decimal is because if we were talking about time and I said, hey, yeah, it's gonna be in 5 and square root of 3 years from now, you'd have no clue what I'm talking about. But if I said about 8.267, so about 8 2/3 of the year, is about how long it would take. So just under 9 years. That is the end of the lesson. Hopefully that helped at all. And I will see you guys next time.